Now, in this lecture, we will find the radius of the red semicircle. In the drawing, we have triangle ABC. Triangle ABC is a right triangle. Angle ABC, this angle equals to 90 degrees. We also know that side AB of triangle ABC equals to 3 units. Line segment DC equals to 1 unit. And the semicircle is inscribed by the right triangle, triangle ABC. And we want to find out the radius of this red semicircle. So, first of all, I will present to you a new rule. Rule number 1 or 2 tangents theorem. Rule number 1 or 2 tangents theorem states that the lengths of 2 tangents from a common external point to a circle are equal. So I will read rule number 1 or 2 tangents theorem again. According to rule number 1 or 2 tangents theorem, the lengths of 2 tangents from a common external point to a circle are equal. So what is the meaning of rule number 1 or 2 tangents theorem? Actually, if we have a circle this blue circle and the center of this blue circle is at this point. This point is defined as point O, and we have a tangent, we have external point P. This point P is an external point of this circle. Why point P is an external point of this circle? Because of the fact that point P is not located inside this circle nor on this circle, but it is located outside this circle. Therefore, it is defined as external point of this blue circle. So if from this external point P will draw 2 tangents to this circle, then actually the first tangent will be this tangent, and we define the touching point between this tangent and the blue circle as point A, and we will draw also the second tangent from point P to that circle, to this circle. And we will define the touching point between the second tangent, this tangent, and the blue circle as point B. Actually, the length of this first tangent is PA, and the length of this second tangent is PB. And according to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So whenever you draw two tangents to a circle from a common external point, like in this example, we draw two tangents from the common external point, point P, to that circle, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay? Again, I repeat again. The length of two tangents from a common external point to a circle are equal. So the length, when we draw two tangents from a common external point, in this example, the common external point is point P, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay? So actually, we can implement the two tangents theorem in our drawing, because in our drawing we have the external point, point A, is an external point of this red semicircle, and from point A we have two tangents to this circle. The first tangent is tangent AB, and we know that tangent AB is actually 3 units in its length, and the second tangent from point A to this red semicircle is AE, and according to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So whenever we draw two tangents from the common external point A to this red semicircle, then the length of those two tangents will be equal to each other. That is to say, AB will equals to AE. AB equals to AE, but we know that AB equals to 3 units. It is given us in the question that AB equals to 3 units, so AB equals to 3. And so from this equality, we will conclude that AE also equals to 3 units. Okay, so here AE equals to 3 units. So in the next step, I will present to you a new rule, rule number 2, and we will implement the rule in our drawing. So actually, rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I will read rule number 2 again. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have a circle, you have this circle, and the center of this blue circle is at this point. We define the center of the circle as point O, and we actually also have tangent to this circle actually tangent AB. This tangent is tangent to this blue circle at this point. We will define the touching point between tangent AB and the blue circle as point M. Actually, point M, it is actually also defined as point of tangency. Point of tangency of tangent AB with this blue circle. Then we will join points O and M together by a straight line. OM will be the radius of this blue circle. Actually, so the radius is R. We define the radius of the circle as R. So this radius OM is drawn to the point of tangency. That is to say, this radius OM is drawn to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. I'll read rule number 2 again. A tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So whenever you have a radius like in this drawing that is drawn to the point of tangency, that is to say this radius is drawn to point M, that is the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also will be equal to 90 degrees. Okay, so that is the meaning of rule number 2. And we can actually implement rule number 2 in our drawing. Because in our drawing we have AC, tangent AC is perpendicular, tangent AC is tangent to this red circle at this point, at point E. Actually, point E is the point of tangency of tangent AC with this red semicircle. Point E is the point of tangency. Of tangent AC with this red semicircle, and we will define the center of this red semicircle as point O. Point O is the center of this semicircle, and actually BO, line segment BO, is the radius of this red semicircle because of the fact that line segment BO starts from point O, that is the center of this semicircle, and ends at point B, that is a point on the semicircle itself. Therefore, BO is the radius of this semicircle, and the radius of the semicircle is defined as R. So BO equals to R. Likewise, OD is also the radius of this semicircle because of the fact that line segment OD starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle, that is to say it equals to R. Then we will join points E and O together by a straight line. Actually, line segment OE is also the radius of this red semicircle because of the fact that line segment OE starts from the center of the semicircle, that is to say from point O, and ends at point E, that is a point on the red semicircle itself. Therefore, OE is the radius of this semicircle, that is to say it equals to R. So here we have the radius OER is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency. Therefore, according to rule number 2, tangent AC is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, because of the fact that the radius OE is drawn to the point of tangency, therefore the tangent AC is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. So because of the fact that angle OEC, this angle equals to 90 degrees, therefore triangle OEC is a right triangle. Okay, triangle OEC is a right triangle. So the green triangle is a right triangle because it has one angle that equals to 90 degrees. So we will focus on the green right triangle, triangle OEC. Okay. In the right triangle, triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle, and especially in the right green triangle, the square of its hypotenuse equals to the sum of the squares of its perpendiculars. The hypotenuse in the green triangle, in the green right triangle, is actually OC, because OC is in front of the right angle. So OC, the square of the hypotenuse, is OC squared, and it equals to the sum of the squares of the perpendiculars, that is to say, it equals to OE squared plus EC squared. I will repeat again. if we focus on triangle OEC, the right triangle OEC, the right green triangle OEC, the square of the hypotenuse equals to the sum of the square of the perpendiculars. That is to say, OC square equals to OE square plus EC square. But what is the value of OC? The value of OC, as you can see from the drawing, the value of OC, it is actually equals to R plus 1. If OC equals to R plus 1, then OC square will be equal to R plus 1 square. And so OC square equals to R plus 1 square. And what is the value of OE? As you can see from the drawing, the value of OE is R. It is the radius of this red semicircle. And so OE equals to R, so OE square will be equal to R square. And if we define EC as X, that is to say side EC equals to X units in its size, then EC equals to X, so EC square will be equal to X square. Okay, so OE square equals to R square and EC square equals to X square. Here we will open the brackets of equation number 1 and we will get that R plus 1 square actually equals to R square plus 1 plus 2R according to the algebraic identity. A square, A plus B square equals to A square plus B square plus 2 times AB, and it equals to R square plus X square. So after we opened the brackets, we got this expression: R square plus 1 plus 2R equals to R square plus X square. Here we will subtract R square from equation number 1, so R square will get cancelled. And what is left from equation number 1 after we cancelled R square? What is left, it is actually one plus 2R equals to X square. So we found out that according to equation number 1, 1 plus 2R equals to X square. Okay, so in the next step we will focus on the right big triangle, triangle ABC, and on the small green right triangle, triangle OEC, and we will prove that those two triangles similar to each other. So we will focus on triangle, the right big triangle, triangle ABC, and the green right small triangle, triangle OEC. So I'll repeat again. We'll focus on triangles ABC and triangle OEC. The green triangle, triangle OEC. Actually, we know that those two angles are equal to each other. They are both right angles. So we can write down that angle ABC, this angle of triangle ABC, equals to angle OEC of the green right triangle, triangle OEC. and both angles are right angles, they are equal to 90 degrees. So actually angle ABC equals to angle OEC, and they are both equal to 90 degrees, they are right angles. Okay, and actually we also know that this angle is a common angle, it belongs to both the big right triangle, triangle ABC, and this angle, angle C, also belongs to the green right triangle, triangle OEC. So we can write down that angle C equals to angle C as a common angle that belongs to both triangles. Okay, angle C equals to angle C as a common angle that belongs to both triangles. And actually those two angles are also equal to each other according to third angle theorem. And I will prove that those two angles are equal to each other. That is to say, this angle, angle BAC in triangle ABC, is equal to this angle, angle EOC in triangle EOC, and those two angles are equal to each other according to third angle theorem. So I'll repeat again. Angle BAC equals to angle EOC according to third angle theorem. So what is third angle theorem? Third angle theorem or rule number 3 or third angle theorem, it is the same. So according to rule number 3 of third angle theorem, if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. I will repeat again on rule number 3 of third angle theorem. According to rule number 3 of third angle theorem, if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So, what is the meaning of rule number 3 of third angle theorem? Actually, the meaning of rule number 3 is that if you have two triangles, triangle ABC this is triangle ABC, and we also have another triangle, triangle DEF. This is triangle DEF. And in those two triangles, we have two pairs of angles that congruent to each other. The first pair of angles that congruent to each other are those angles. This angle equals to alpha, and this angle also equal to alpha. So this is the third pair of angles that congruent to each other. And those two triangles also have a second pair of angles that congruent to each other. This angle is beta, and this angle also equals to beta. So this is the second pair of angles that congruent to each other. They are both equal to beta. And if this angle equals to gamma, and this angle equals to theta, so if this is the situation, then those third pair of angles must also congruent to each other. That is to say, angle gamma equals to angle theta. According to rule number 3 of third angle theorem, angle gamma equals to angle theta. So whenever you have two pairs of angles that congruent to each other, then the third pair of angles must also congruent. That is to say, angle gamma equals to angle theta. And I will actually prove that angle gamma equals to angle theta according to the rule that states that the sum of the angles in any triangle equals to 180 degrees. Therefore, in triangle ABC, we know that the sum of its angles equals to 180 degrees. That is to say, here alpha plus beta plus gamma must be equal to 180 degrees, according to the rule that I stated, that the sum of the angles in any triangle equals to 180 degrees. Therefore, the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, this triangle, the sum of its angles equals to 180 degrees. So in triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta must be equal to 180 degrees according to the rule that I stated. Likewise, in triangle DEF, the sum of its angle angles must be equal to 180 degrees. That is to say alpha plus beta plus theta equals to 180 degrees. Here we will subtract equation number 1 from equation number 2, and we will get that alpha minus alpha equals to 0, beta minus beta equals to 0, and gamma minus theta equals to 180 degrees minus 180 degrees. So we actually got that according to equation number 3, gamma minus theta equals to 0. So here we will add theta to this equation number 3, and we will get that angle gamma equals to angle theta. Okay, so actually we found out that angle gamma equals to angle theta, and that is exactly what we wanted to prove. We wanted to prove that angle gamma equals to angle theta. We proved indeed that angle gamma equals to angle theta. And again, I will repeat the rule number 3 or 2 tangents theorem again. If we know that in two triangles, two pairs of angles can go into each other, then the first pair of angles must also congruent, that is to say angle gamma equals to angle theta, and I proved that indeed angle gamma equals to angle theta in those two triangles. Angle gamma equals to angle theta. So we will return to our original drawing. If in our original drawing we actually proved that all three angles of triangle ABC congruent to all three angles of the green right triangle, triangle OEC. Okay, and therefore we actually proved that triangle ABC, the big right triangle, is similar to triangle OEC, the green right triangle, according to angle similarity rule. So I'll write it down. We actually proved the triangle ABC, the big right triangle, is similar to triangle OEC, the right green triangle, this triangle, according to angle similarity rule. I will repeat again. We actually proved the triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle can go into all three angles of another triangle, then you proved that those two triangles are similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to the green triangle, triangle OEC, we will conclude that AB over AC in triangle ABC, AB over AC in triangle ABC, equals to OE over OC in triangle OEC. I will repeat again. From the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC equals to OE over OC. Okay. But what is the value of AB? AB equals to 3 units. AB equals to 3 units according to what is given us in the question. What is the value of AC? The value of AC, it is actually 3 plus X. As you can see it from the drawing. So AB over AC, it is actually 3 over 3 plus X. And what is the value of OE? The value of OE is the radius of this right semicircle. So OE equals to R, as you can see from the drawing. What is the value of OC? The value of OC is actually R plus 1. As you can see from the drawing, OC equals to R plus 1. So here OE equals to R and OC equals to R plus 1, and in total we got that 3 over 3 plus X equals to R over R plus 1. Here we will cross multiply equation number 2. And we will get that 3 times R plus 1 equals to R times 3 plus X. Okay, we cross multiplied this equality and we got to this expression that 3 times R plus 1 equals to R times 3 plus X. Here we will open the brackets of equation number 2 and we will get that 3R plus 3 equals to 3R plus R times X. Okay, so according to equation number 2, 3R plus 3 equals to 3R plus R times X. Here we have 3R on both sides of the equation, so we'll subtract 3R from equation number 2, this equation. So 3R will get cancelled. And what is left after we cancelled 3R? What is left? It is actually 3 equals to R times X. So we found out that 3 equals to R times X. Here we will divide this equation number 2, by X. And why it is allowable to divide equation number 2 by X? Maybe X equals to 0, and then it is not allowed to divide the equation by 0. But as you can see from the drawing, EC is one side of the green triangle, EC equals to X, or X is equals to EC, so it is one side of the green triangle, and the side of a triangle must be a positive number, it can never be 0, therefore it is allowable to divide this equation number 2 by X. So after we divide equation number 2 by X, we will get that the radius of the semicircle equals to 3 over X. The radius of the semicircle R equals to 3 over X. This is according to equation number 2. But according to equation number 1, we've already found out that 1 plus 2r equals to x squared. This is what we have already found out in equation number 1, that 1 plus 2r equals to x squared. So here we can substitute 2r in this equation, equation number 1, by 3 over x, because r equals to 3 over x, according to equation number 2. So we'll do it now, and we'll get that 1 plus 2 times, and instead of r, we write down 3 over x, that equals to r. 3 over x equals to x squared. Here, 2 times 3 is 6, so we write it down. We get that 1 plus 2 times 3 is 6 over x equals to x squared. So we found out that according to equation number 1, 1 plus 6 over x equals to x squared. Here we will multiply equation number 1 by x, and we will get that x times 1 is x, 6 over x times x is 6, and x squared times 6 is x cubed. So here we will subtract x from this equation, equation number 1, and we will get that x cubed minus x equals to 6. Here we will subtract 6 from equation number 1, this equation, and we'll get that x cubed minus x minus 6 equals to 0. Okay? So here, actually we know that minus 2x squared plus 2x squared equals to 0. It equals to 0, and it is allowable to add 0 to any equation. So we will add this expression to this equation number 1 because it equals to 0, and it is allowable to add 0 to any equation. Okay, we'll do it now, and we will get that x cubed minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. Okay? Here we will substitute minus x. We know that minus x equals to minus 4x plus 3x. So we will substitute minus x in equation number 1, this equation, by minus 4x plus 3x, that equals to minus x. And we will get that x cubed minus 2x squared plus 2x squared, and we'll substitute minus x by minus 4x plus 3x minus 6 equals to 0. So after we substituted minus x, we got this equation number 1. So here we divide this equation number 1 to 3 parts, and we will take a common factor from each part. Okay, so this will be the first part. This will be the second part. And this will be the third part. So now we will take a common factor from each part. We will take a common factor from part 1. Part 1, it is actually x cubed minus 2x squared. And the common factor that we will take from this expression will be x squared. So what is left from x cubed after we took x squared as a common factor? What is left? It is actually x. And what is left from minus 2x squared after we took x squared as a common factor? What is left? It is actually minus 2. We'll repeat on the same process on the second expression. The second part, it is actually 2x squared plus 4x, 2x squared minus 4x, 2x squared minus 4x. Here, the common factor that we take from this expression will be 2x. So 2x is a common factor. So what is left from 2x squared after we took 2x as a common factor? What is left? It is actually x. And what is left from minus 4x after we took 2x as a common factor? What is left? It is actually minus 2. We will repeat on the same process on the first part. The first expression is actually 3x minus 6. And the common factor that we will take from this expression will be 3. So what is left from 3x after we took a common factor 3 from it? What is left? It is actually x. And what is left from minus 6 after we took a common factor 3 from it? What is left? It is actually minus 2. Okay, so actually we have here 3 expressions that are identical to those 3 expressions. So we can substitute this expression by this expression. We can substitute this expression by this expression because they are equal to each other, and we can substitute this expression by this expression because they are equal to each other. So we will do it now, and we know that the sum of those 3 expressions equal to 0. Therefore, the sum of this 3 expressions will be also equal to 0. So we'll substitute this expression by this expression. We'll get x squared times x minus 2. Here we'll substitute this expression by this expression that equals to it. And we will also substitute this expression by this expression that equals to it. And we know that the sum of those three parts equals to 0, therefore the sum of those three parts will be also equal to 0. Okay, this expression, equation number 1, is identical to this expression. So we will take a common factor of x minus 2 from this equation number 1, and we will get that so x minus 2 is a common factor. What is left from this expression after we took x minus 2 as a common factor? What is left? It is actually x squared. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 2x. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 3. And we know that all equals to 0. Okay, so actually that is the equality that we got after we took x minus 2 as a common factor of equation number 1. So here we have two solutions that are possible for this equation number 1. Either x minus 2 will be equal to 0, or the other possibility is that x squared plus 2x plus 3 equals to 0. Okay, because if it equals to 0, then 0 times anything will be 0, and we will get the equality that 0 equals to 0. So we write down those two possible solutions to this equation number 1. So the first possible solution for this equation number 1 is that x minus 2 equals to 0. And the second possible solution to this equation number 1 is that the quadratic equation x squared plus 2x plus 3 equals to 0. So, as I already said, this equality is a quadratic equation, and actually the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. Actually x equals to minus b plus minus square root of p squared minus 4 times a times c over 2a. Okay, that is the way that we can find out the value of x. By using this formula, we will find out the value of x, that is the variable that we are looking for. And this is for the general equation, but in our specific quadratic equation, the values of its coefficients are as follows. Here the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to 3. So we will put the data inside this formula in order to find out the value of x that we are looking for. And so we will put the data inside this formula for x. and we will find out the value of x. So here, according to the formula, x equals to minus b. We know that b equals to 2, so minus b will be equal to minus 2 plus minus square root of b squared. B equals to 2, so b squared is 2 squared, 2 squared is 4, minus 4 times ac, minus 4 times a is 1, c is 3. So it is minus 4 times 1 times 3 over 2a. 2 times a is 1. 2 times 1 is 2. So we get that x equals to minus 2 plus minus square root of 4 minus 4 times 1 times 3 is 12 over 2. So we continue to solve this formula. X equals to minus 2 plus minus square root of 4 minus 12 is minus 8 over 2. So here we have minus 8 inside the root, and because of the fact that minus 8 is a negative number and a negative number doesn't have a root, therefore we can conclude that this quadratic formula, this quadratic equation doesn't have a solution because we are stuck here because of the fact that while we trying to solve out this quadratic equation, we get stuck here. We're stuck here because the negative number 8 doesn't have a root. Therefore, we will conclude that this quadratic equation doesn't have a solution. Therefore, this possibility is cancelled, and we left only the possibility that the solution for equation number 1 is that x minus 2 equals to 0. Okay, so x minus 2 equals to 0. So if x minus 2 equals to 0, then x equals to 2. We found out that x equals to 2. But we've already found out that according to equation number 2, the radius of the semicircle equals to 3 over x. The radius of the semicircle equals to 3 over x, and we know that x equals to 2. So we can put the value of, we found out that the value of x is 2, so we can put 2 inside this equation, and we get that the radius of the semicircle equals to 3, and x is 2, 3 over 2 units, or we can represent it as the radius of the semicircle equals to 1.5 units. Okay, so I will repeat again. The radius of the semicircle equals to 3 over 2 units, or we can represent 3 over 2 as 1.5 units. I will repeat again. The radius of this red semicircle R equals to either 3 over 2 units or it equals to 1.5 units. Okay, now I will summarize the lecture. Actually, we wanted to find out the radius of this red semicircle. We have triangle ABC. We know that AB equals to 3 units, angle ABC is 90 degrees, side DC is 1 unit, and we want to find out the radius of this semicircle. So first of all, I presented to you a new rule number 1, or two tangents theorem. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1, or two tangents theorem? The meaning of two tangents theorem is that if we have this blue circle and we have the external point P of this blue circle, point P is an external point because it is not located inside this blue circle nor on this blue circle, but it is outside the blue circle, therefore it is defined as external point. So from point P, if we draw two tangents from point P to this blue circle, so the first tangent will be PA, and the length of the first tangent is PA. The second tangent, this is the second tangent, and the length of the second tangent is PB. According to rule number 1, or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So whenever you draw from a common external point, in this case is point P, two tangents to a circle, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB in this case, okay? So whenever you draw two tangents to a circle from an external point of a circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. Okay, that is the explanation of two tangents theorem, and we actually can implement rule number 2, rule number 1 in our drawing, because in our drawing we have the external point A, and we have tangent AB to this right semicircle, and we know that the length of tangent AB is 3 units, and we also have the tangent AE to this right semicircle. And according to rule number 1, the lengths of two tangents, when we draw them from an external point of a circle to that circle, then the length of those two tangents will be equal to each other. That is to say, AB equals to AE. AB equals to AE according to rule number 1, but we know that AB equals to 3 units. So from this equality, we will conclude that AE also equals to 3 units. AE equals to 3 units, that is to say, this line segment equals to 3 units. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this blue circle, and we know that the center of this blue circle is at point O, and we have tangent AB. Tangent AB is tangent to this blue circle as point M. Point M is the point of tangency of tangent AB with this blue circle. Then we have a radius. This radius, OM, is drawn to the point of tangency. Therefore, according to rule number 2, whenever you have a radius that is drawn to the point of tangency, then the tangent AB will be perpendicular to this radius. Okay? A tangent to a circle, that is to say tangent AB, is perpendicular to the radius that is drawn to the point of tangency. This radius OM is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, so we can implement rule number 2 in our drawing, because in our drawing we have the tangent AC that is tangent to this right semicircle at point E. Point E is the point of tangency of tangent AC with this with this red semicircle, and we have the radius OE. This radius is drawn to the point of tangency, that is to say, it is drawn to point E, that is the point of tangency. Therefore, the tangent AC is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And because of the fact that angle OEC equals to 90 degrees, therefore, the green triangle OEC is a right triangle. Okay, so we will focus on the green right triangle OEC. On the green right triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. OC equals to R plus 1, as you can see here. OC equals to R plus 1, OE equals to R, it is the radius of this red semicircle, and EC equals to X. Therefore, in total, we will get that OC square equals to OE square plus EC square. It means that R plus 1 square equals to R square plus X square. Okay, here we open the brackets in equation number 1. R plus 1 square equals to R square plus 1 plus 2R, and it equals to R square plus X square. Here we will subtract R square from equation number 1, from this equation, and we will get that 1 plus 2R equals to X square according to equation number 1. Then we focus on the right big triangle ABC, and on the small green right triangle OEC. And we prove that those two triangles are similar to each other. We know that those two angles are equal to each other, they are both right angles. So angle ABC equals to angle OEC, they are both equal to 90 degrees, they are right angles. We also know that this angle is a common angle, it belongs both to the angle ABC, and it also belongs to the green triangle OEC. Therefore, we can write down that angle C equals to angle C is a common angle that belongs to both triangles. Then, actually, these two angles are also equal to each other according to third angle theorem. That is to say, angle BAC in triangle ABC equals to angle EOC in triangle EOC according to third angle theorem. Okay, so what is for the third angle theorem of rule number 3? Rule number 3 of third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3 of third angle theorem? The meaning of third angle theorem is that if you have those two triangles, this is triangle ABC, and this is triangle DEF. Those two triangles have two pairs of angles that can congruent to each other. This is the first pair of angles that can congruent to each other. They are both equal to alpha. Those two angles, they are both equal to alpha. And this is the second pair of angles that can congruent to each other. Those two angles are both equal to beta. So we have in those two triangles two pairs of angles that can congruent to each other. Those two pairs of angles can congruent to each other. So if this is the situation, then the third pair of angles must also congruent to each other. That is to say, angle gamma equals to angle theta. And I actually proved that the third angle theorem is true. That is to say, I proved that angle gamma equals to angle theta. How? I rely on the rule that states that the sum of the angles in any triangle equals to 180 degrees. And especially in triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. in triangle ABC, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. This is equation number 2, that alpha plus beta plus theta equals to 180 degrees. And then we subtract equation number 1 from equation number 2. And we got that alpha minus alpha equals to 0, beta minus beta equals to 0, and gamma minus theta equals to 180 degrees, minus 180 degrees is 0. We found out that gamma minus theta equals to 0 according to equation number 3. Then we added theta to equation number 3, and we found out that angle gamma equals to angle theta, and this is exactly what we wanted to prove. We wanted to prove that angle gamma equals to angle theta, and we indeed proved that angle gamma equals to angle theta. So we actually proved if we have two pairs of angles that are equal to each other in two triangles, then the third pair of angles must be also equal to each other. That is to say, angle gamma must be also equal to angle theta, and we actually proved that angle gamma equals to angle theta. Okay, then we we return to our original drawing. In our original drawing, we actually proved that triangle ABC has three angles that can went to triangle EOC, the green triangle. Therefore, we proved the triangle ABC similar to triangle EOC according to angle similarity rule. We proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you have three angles of one triangle that can went to three angles of another triangle, then you actually, if you prove that three angles of one triangle can went to three angles of another triangle, then you actually proved that those two triangles similar to each other according to angle similarity rule. From the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. AB over AC in triangle ABC equals to OE over OC in triangle OEC. What is the value of AB? AB equals to 3 units. AC equals to 3 plus X units. So AB equals to 3 units. AC equals to 3 over X units. OE equals to R, OC equals to R plus 1. OC equals to R plus 1. Again, OE equals to R, OC equals to R plus 1. So in total we got that 3 over 3 plus X equals to R over R plus 1. Here we cross multiply the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. Okay. Here we open the brackets in equation number 2, and we got that 3r plus 3 equals to 3r plus rx. Here we subtracted 3r from equation number 2, so 3r will get cancelled. And what is left after we cancel 3r? What is left? It is actually 3 equals to rx. We divided this equation by x. It is allowable to divide equation number 2 by x because x can never be 0. X is the side of a triangle, and the side of a triangle can never be 0. Okay, so we divided equation number 2 by x, and we got that the radius of the semicircle equals to 3 over x. And that is according to equation number 2, but we have already found out that 1 plus 2r equals to x squared according to equation number 1. So here we can substitute 2r in equation number 1 by 3 over x, because r equals to 3 over x according to equation number 2. So we substituted r by 3 over x, and we got that 1 plus 2 times 3 over x equals to x squared. 2 times 3 equals to 6. So we got that 1 plus 6 over x equals to x squared. we multiplied this equation number 1 by x, and we got that x plus 6 equals to x cubed. Here we subtracted x from this equation number 1, and we got that x cubed minus x equals to 6. Here we subtracted 6 from this equation, and we got that x cubed minus x minus 6 equals to 0. We know that minus 2x squared plus 2x squared is 0, and we can add 0 to any equation, so we added this expression that equals to 0 to equation number 1, this equation, and we got this expression. And then we substituted minus x in this equation number 1 by minus 4x plus 3x. Minus 4x plus 3x equals to minus x, so we substituted minus x by minus 4x plus 3x, and we got this expression. And here we divided equation number 1 to 3 parts, and we took a common factor from each part. So part number 1 is x cubed minus 2x squared, and the common factor that we took from this expression is x squared, and inside the brackets what is left is x minus 2. Then we took a common factor from 2x squared minus 4x. The common factor that we took from this expression is 2x, and what is left inside the brackets is x minus 2. And we took a common factor from 3x minus 6. The common factor that we took from this expression is 3, and what is left inside the brackets is x minus 2. So we substituted this expression by x squared times x minus 2. We substituted this expression by 2x times x minus 2, and we substituted 3x minus x by 3 times x minus 2. And we know that the sum of those three expressions equals to 0, so the sum of those three expressions will be also equal to 0, so we got this equation number 1. Here we took a common factor of x minus 2 from this equation number 1. And then, actually, after we took a common factor of x minus 2, what is left from this expression, after we took x minus 2 as a common factor, is x squared. What is left from this expression after we took a common factor of x minus 2, it is actually 2x, and what is left from this expression after we took x minus 2 as a common factor, what is left, it is actually 3. So in total we got this equation number 1. Here we have two solutions that are possible to equation number 1. Either x minus 2 will be equal to 0, or either x cubed plus 2x plus 3 will be equal to 0. Then we focused on the second solution, that x squared plus 2x plus 3 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to this special formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, the coefficients are as follows: a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this formula in order to find out the value of x that we are looking for. So we found out that x equals to minus b. B is 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c. Minus 4 times a is 1, c is 3, so it is minus 4 times 1 times 3 over 2a. A is 1, so 2 times 1 is 2. So we solve this equality, x equals to minus 2 plus minus 4 times 1 times 3 is 12. So in total we got inside the root that it is 4 minus 12. Here it is 4 minus 12 because 4 times 1 times 3 is 12. So here inside the root we have 4 minus 12. 4 minus 12 is minus 8. So we have minus 8 inside the root, and a negative number doesn't have a root. Minus 8 is a negative number, and the negative number doesn't have a root, therefore we are stuck here. That means that this quadratic equation doesn't have a solution. So we will abandon this possibility because this possibility is not true, and the only possibility that is left for the solution of this equation number 1 is that x minus 2 equals to 0. And if x minus 2 equals to 0, then x equals to 2. And we have already found out that according to equation number 2, the radius of the semicircle equals to 3 over x. So we can put x that equals to 2 inside this equation number 2. So we put x equals to 2 in this equation number 2, and we got that the radius of the semicircle equals to either 3 over 2 units, or it also can be represented as 1.5 units. I will repeat again, the radius of this red semicircle R equals to either 3 over 2 units, or it equals to 1.5 units. Okay, thank you very much.